Have you ever looked up at the night sky and wondered, are we really all alone? Or maybe, is our future even on this planet? Today, we are diving into one of the biggest adventures humanity has ever dreamed of, our journey to understand, to explore, and maybe, just maybe, one day to live on the red planet, Mars.
So let's just kick things off with a pretty wild idea, a quote that kind of flips everything you think you know on its head. We are all Martians. Now, I know it sounds like something straight out of a movie, but it's actually tied to a really fascinating scientific theory that has been fueling our obsession with Mars for years. And that theory is called panspermia. The idea is this: what if billions of years ago, Mars was the planet with life? And what if a massive asteroid hit Mars, blasting rocks with tiny microbes into space, and one of those rocks eventually crashed right here on Earth? If that's true, then searching for life on Mars isn't about finding aliens, it's about finding our own family tree, our most distant ancestors. But look, a theory is just a theory, right? You need proof. And to get that proof, well, we actually had to go there. Which brings us to our first robots on Mars, starting with the legendary Viking mission. Picture this, the year is 1976. NASA's Viking lander touches down on Mars. It is the very first time we have ever successfully landed something on another planet. And what's the first picture it sends back? This incredible, rocky alien landscape, and, I love this, a picture of its own foot, basically saying, we're here. Now, you have to appreciate how they pulled this off. I mean, this was the 70s. The lander snaps a photo. Then its little antenna zaps the data millions of kilometers up to an orbiter. That orbiter then bounces the signal all the way back to Earth, where it's recorded on these huge, old-school magnetic tapes. Just an absolutely incredible feat of engineering for its time. And Viking, man, it was a workhorse. It was only supposed to last for 90 days. Instead, it kept going for over 6 years. It sent back 50,000 images, giving us our very first real look at Mars, the red dirt, the massive plains, the mountains. But after all that searching, the big answer about life was still a maybe. No definitive proof. But it did leave us with one amazing, tantalizing clue. In one of the photos, you could see this thin white layer under some rocks. The big question was, what was it? Was it frozen carbon dioxide, basically dry ice, or was it frozen water? And that difference? Well, that difference is everything. Because if it's water, the chances for life just go through the roof. So Viking left this giant question mark hanging over everything. We needed a new mission, one built for one specific purpose: to dig. That brings us to our next chapter, the hunt for water. All right, let's fast forward to 2008. Meet the Phoenix lander. Its whole job was simple, but so important. Get to Mars and scratch beneath that red soil to find out what that white stuff really was. It even had this cool robotic arm, kind of like a heron's beak, designed just to dig in and get us an answer. So Phoenix lands and it gets right to work. As its arm starts scraping away that top layer of Martian dirt, everyone back at Mission Control is just glued to their screens. And then they see it, a clear glint of white. It looked just like snow. Phoenix scooped up a sample, popped it into its own little onboard lab, and sent back the news that changed the game completely. It wasn't dry ice, it was water ice. For the first time ever, we had touched water on another planet. And finding that water, well, that was like firing the starting gun. The whole conversation shifted. It wasn't if we could go to Mars anymore, it became when and how. And that kicked off a brand new space race, the race to colonize Mars. And just look at who's in the race now. It's not just the US and Russia anymore. You've got private companies like SpaceX totally changing the game with reusable rockets. You've got the old pros at NASA, and you've got new players like the UAE jumping in. Everybody wants to be the first to build a human city on another world. But getting there is an incredible challenge, and it is all about timing. This number you're seeing, 50.5 million kilometers, that's the absolute closest Earth and Mars get to each other. That's the sweet spot. That's your launch window. Because if you miss that window, well, the planets keep moving, and they can drift as far apart as 400 million kilometers. It's this cosmic dance that means you only get one perfect shot to launch a mission every 2 years. You miss it, you're waiting on the bench for 2 more years. So the plan isn't just to blast off from Earth and head straight for Mars. The smartest strategy, the one most people are focused on, is to go back to the moon first. We'd build a permanent base there to act as a kind of interplanetary truck stop, a place to assemble and launch the much bigger, much longer missions to Mars from there. So we figure out how to get there. But once you land, how do you stay alive? That's the real test. And that brings us to the next challenge, surviving on the red planet. First things first, you need power, and a lot of it. So what about solar panels? Well, the sun's way farther away, and massive dust storms can block out the light for months at a time. So that's not reliable enough. Okay, what about fossil fuels? No way, you'd have to ship every single drop from Earth. Totally impractical. So the solution, and this might sound a little surprising, is actually nuclear power. Small, super reliable nuclear reactors can provide a steady, powerful stream of energy 24/7, no matter what the weather is like. They'd be the heart of the colony. And this slide right here shows you exactly what that power is up against. I mean, just look at this comparison. The average temperature is -60°C. The air is basically unbreathable carbon dioxide. The pressure is so low, your blood would literally boil without a suit. And with no magnetic shield like Earth's, you're getting blasted with deadly radiation. It's an incredibly hostile place. So how in the world do you survive that? Well, this is where human ingenuity really shines. We'll need advanced suits just to step outside. For shelter, we won't ship buildings, we'll build them there, like igloos, out of Martian clay and its own frozen CO2. We'll grow our own food in closed-loop aquaponics systems with fish and vegetables. And for water, we'll melt the massive ice caps that Phoenix proved were there. But surviving is just step one, right? That's just about not dying. The long-term vision, the real dream, is so much bigger. Which leads us to our final thought. Could this really be humanity's next home? And that dream has a name: terraforming. It's the ultimate goal. The idea is to slowly, over maybe hundreds or even thousands of years, warm up the planet, release all the CO2 trapped in the ice to thicken the atmosphere, and maybe, just maybe, turn that red planet into a second blue one. And that leaves us with one last big question to think about. Building a new civilization on another world might be the single greatest technical challenge we have ever faced as a species. But as we aim for the stars, you have to ask, which mission is truly harder? Conquering the challenges of space, or figuring out how to live together peacefully right here on the amazing planet we already call home?